Today we're looking at preparing to integrate, and we've got to consider the same things that we did when we were differentiating. So for example, we're going to use index rules to move any x's from underneath a fraction. Remembering that it's only the x that's going to move. So 2 over 3x to the 5 is the same as 2/3 x to the negative 5. We also need to deal with square roots or roots of any order. Like in these examples here. Square root of x, remember, is to the power of a half. If it's under a fraction, it's also negative. Remembering that the numbers don't move with the x, they stay where they are. So we're going to go straight to our notes. Be page 4. The first example asks us to integrate 1 over x squared. Now it's written in a strange way, but what you see there is the same as 1 over x squared dx. Remember, the dx is the notation that we use in integration when we're integrating with respect to x. So when you see the dx on the top like this, you can separate it. The other thing that's a little bit additional information here is it says x can't be equal to 0. And that's just because in this function we're dividing by x squared and we're not allowed to divide by 0. So we're going to go ahead and integrate, but we can't integrate in the form it's in. So I'm going to do a little bit of using the index rules there and make it x to the negative 2. Now I can integrate. So I'll increase the power by 1, which is negative 1, divide by the new power, and remember my constant of integration. Now I need to tidy up. Dividing by negative 1 just means that I can make everything negative. X to the power of negative 1 means that I want 1 over x plus my constant of integration. That was a fairly simple function, but there was quite a lot of work I had to do before I integrated and then afterwards. At this stage, don't rush any of these questions, take your time. The second example. Now I can see that the dx is on the top again, so I know I'm going to move that to the side, and it's 1 over the square root of x. So I'm going to use my index rules. X is on the bottom, so that means I'm going to give it a negative. It's a square root, so it's the power of a half. Now I'm in a position to integrate. So I'm increasing the power by 1. 1 more than negative a half is positive a half. Dividing by the new power and adding the constant of integration. Generally we don't like to have a fraction on a fraction, but in the first instance put it there and we'll tidy it up afterwards. Dividing by a half is the same as multiplying by 2, so that's the same as 2. The power of a half tells us it's a square root of x plus c. This time we're asked to integrate an expression in terms of p. With respect to p, it works in exactly the same way. I'm going to just get the 7/2 out of the way, and that's the same as 1 over p squared. I don't like the p squared on the bottom, so I'm going to use my index rules, and it will be p to the negative 2. Now I'm ready to integrate. So that is equal to 7/2 multiplied by p, increasing the power by 1, dividing by the new power, remembering my constant of integration. Dividing by negative 1 just means I can multiply the whole thing by negative 1. So I'm going to have negative 7/2. P to the negative 1 means p is going to be down on the bottom beside the 2. So I'm going to have negative 7 over 2p plus c. And our last example is on page 5. So I've got a really big fraction here. I'm going to split it up into 2. So I've got 3x to the 5 over 4. And subtract 5x over 4. I'm going to just pull out the constants to make things less cluttered. So I've got 3/4 times x to the 5 minus 5/4 times the integral of x. Now I can integrate. So that's equal to 3/4 times x to the 6 over 6. That's this first part. Take away 5/4 times x squared over 2 plus the constant of integration. Now before I go on, I'm just going to simplify here. So that's 1 and that's 2. I can't do anything with that one. So I'll end up with x to the 6 over 4 times 2, which is 8, minus 5x squared over 4 times 2, which is 8, plus c. And I could combine them both because they have the same denominator. So it's x to the 6 minus 5x squared all over 8 plus the constant of integration. Okay, now you know all of the skills for these, it's just there's quite a lot of things that can come up in one question. You need to take your time and do everything one step at a time. Don't try and jump over 2 steps. Take the time and do it properly. Okay, let's just check where we are. What sort of things do you need to be looking for before you're ready to integrate? You want to be doing some tidying up before you start. Can you integrate this expression? You're now ready for exercise 9i. These questions are much trickier. We're moving out of the unit level and into exam level. 1a to m are level C and n to t are level AB.